In this video, we will take a look at the house with the wrap-around porch, and I will provide you with a few details and things to consider if you're going to be building a wrap-around porch or even a home like this one here. So let's go ahead and take a look at all of the openings, starting with the door coming out of the living room into the backyard. And the master bathroom door. This would be a door coming out of the master bedroom bathroom area. Next up, let's go ahead and head over to the laundry area. And we're going to have a wash machine and a dryer in this room here, along with a section of the house that will go all the way through from the front porch to the back porch. And I believe the original design had a garage over here somewhere. And if that's something you're interested in, let us know, and then I will go ahead and draw the garage for this particular project. And let's not forget, wherever you have lumber in contact with the concrete, that it might need to be treated also. And of course, our front door. And our front door will have a 2.5-inch drop down here, along with all of the other doors that will have access to the wraparound porch, so that we will have a 1-inch step down after we install our 1.5-inch thick decking. And don't forget to check with your local building codes, because this step down might need to be even shorter. Next up, let's go ahead and head over to the footing. And I'm not going to provide you with information for every single footing. Let's just go ahead and go over one of them, where we have a heavy-duty post-base connector going into the concrete. And even though I don't have any rebar in this example, you can always install rebar in your concrete footings to make them a little stronger. And I also like to hold the post base connectors just a little bit off of the concrete, maybe the thickness of this particular part of the connector, to provide me with a little more separation between the wood and the concrete. Next up, let's go ahead and take a look at the connection for the ledger. And in our example here, we are using treated lumber with anchor bolts. And our anchor bolts have square washers on them. You might not need them. You might be able to get away with using round washers, or even different types of connectors. And of course, the hangers for the deck joist. And in this example here, we have 2x6 that are going to connect to a 4x8. And we are using 2x8 for our ledger. Let's go ahead and swing around, get another view here. And in this example, we are using 1/2-inch diameter anchor bolts and spacing them about 32 inches on center. Next up, let's go ahead and take a look at the post to beam connectors, and you can use a variety of different methods to make this structural connection. However, the most common one is going to be one that looks like this one here. And of course, this one here can get in the way of the joist hangers, but it's not going to be a big deal most of the time, because the hanger can simply go over the connector. And if you need to, you can always drill holes through any of the hardware if necessary to drive a nail into it. Next up, let's go ahead and take a look at the corner, where we are going to use a couple of different straps. A corner strap here, we're going to wrap it around to connect the two beams together. And of course, I have a smaller strap and a larger strap to provide you with two more examples. However, the larger strap is going to be better. Get a nice connection from the bottom post and the beam to the upper post. And don't forget that these are only suggested methods of assembly. Your contractor or engineer might have another method. And I don't see any reason for installing any hardware in here because of the 45-degree angle and the strap going around the outside. However, the post might need a little more structural support to prevent it from moving. So one method there. Let's go ahead and take a look at another one where we have a shorter strap going over a post to beam connector here. And we could always add another strap to the inside to make a nice connection there. along with this method here, where there might be a hanger and a joist a little too close to make some of the other connections work. And since we do have a beam on each side with a break in the center here, we will probably need to add a strap to connect these two beams together, and of course another strap here to connect the posts to the two beams and then to the other post. So another method there. Let's go ahead and take a look at one more method here where we are going to use a long strap and a couple of framing anchors here. And of course these framing anchors can be installed at the bottom also to connect this post to the beam in the same way we're connecting this post to this beam here. And of course another strap, a smaller strap. And for those of you who do not want to see any building hardware, after you have installed the decking and maybe some fascia on the outside of the deck to cover the straps that are going to be on the other side, then you should take this into consideration when selecting your post to beam connecting hardware. And even if I installed a board on the outside here, like some form of deck fascia board, you'd still be able to see this right here and quite possibly the bottom of the strap. And if you don't want to see that, again, look for another type of building hardware. And for the most part, we can use these connections below and the connections that I have already showed you to connect the beams to the post also. And of course, we could put the straps on top of the beams, or even move this strap up a little higher if we wanted to use a little longer strap, or even install two straps on one side, or one strap on one side, one strap on the other side. And again, we could use the same methods below in the same way that we use the post to beam connector. And I would imagine most engineers are going to call out for some type of hardware like this because it's what they're most familiar with. However, I think some of the strap connections like we have below might provide us with a stronger structural connection. However, with that said, I need to point out I am not an engineer, so would only be speculating on that thought. And what I did here, instead of just kind of going 8 foot on center with the posts, was to equally space them according to the length of each side so that I don't end up with one of these sections that is ridiculously large or small, or even just have a 2 foot variation. For example, have an 8 foot spacing, 8 foot spacing, 8 foot spacing, and then a 2 foot spacing or a 4 foot spacing. And again, I will leave it up to you whether or not that makes sense. And of course, that will be one of those things that you will need to consider when figuring out the design of your deck. And our joists are spaced 16 inches on center. If you are going to install different types of decking boards, you might need to space them a little closer, or you even might be allowed to space them farther apart. And we will need to use a special hanger where the joist connects to the 45-degree angle ledger here. And we will end the video by taking a tour around the deck framing here. And depending upon the design, I didn't run the ledger all the way through, because it often doesn't look nice to have the ledger run through and then look at this on the outside. It looks a lot better to have something like this. And again, that's only if that's going to work for your design. And of course, another helpful tip when building decks around angled perimeter walls and building foundations might be to extend the length of the edge of one of the ledgers so that you could get better nailing for a hanger. So if you could just imagine this line here coming out, it would come maybe over to here, which would make it a little more difficult to install this type of hanger. And you could even run the ledger all the way over to the other joist here if this needed to come over even further to create a better connection in an area where you're not going to be able to make a nice connection. In this video, I will walk you through the process of laying out a 6-step winder section of a stairway. And to do this in this example, we're going to start with a 6 foot by 6 foot square that you can lay out. And the first method might not be necessary, but I'm going to show it to you anyway because this might be helpful for you. And in that method, we're going to take a 2 foot radius. You can change it and make it larger or smaller if it's going to work better for your project. And then we're simply going to divide this into 6 units. Or you can divide it into 3 units on each side of a diagonal line that will connect from corner to corner. And I'm not going to go into much detail on this because I think I've created an easier method and one that will not require you to do a lot of math. And that would simply be to measure over the distances that I have here for your 6 foot square, even if your stairway is only going to be 3 foot wide. And this method should work just fine when measuring out a variety of different stairway lengths or stairway sizes. And if you notice, this measurement here is the same as this one. This measurement here is the same as this one. And this one will be the same as this one. And for those of you who cannot see it, this measurement here is 1 foot 7 5/16 inches. This one here is 1 foot 10 1/4 inches. And this one here is 2 foot 6 7/16 inches. And after you have laid out these measurements, you can connect the straight lines from those measurements back to the center or corner of our square box. And then we are going to take a 6-inch square, and you can just do this with a framing square. You don't need to make a separate square for this. And then we're simply going to slide it over until we have it lining up with this point right here. And again, this can be done with a framing square, just simply lining up the framing square with the 6-inch measurement there. And I do have other videos on that at our website for laying out a variety of different types of winders that I would suggest watching also if this doesn't make sense. And then once you have this mark here, you can simply create a straight line up to this point right here where it intersects into this line here. And then square off of that and go back here, or simply measure the distance down here and then measure the distance up here and then square off of this line here until it connects and meets right here. And then you're simply going to pull off of this line here a measurement of 3 feet or whatever size you're going to need for the width of your stairway to provide you with the desired layout you're going to need. So this one right here is 3 feet, and we're coming off of this point square to create a square inside of our winder stairway. And if I want to make it wider than 3 feet, then all I need to do is extend these lines outward a little further and then move these lines over. And before I do that, I just kind of wanted to point out here that most building codes require a 6-inch minimum distance here. And since that is the minimum distance and they can be larger, you're probably not going to have a problem with these measurements here. However, if you are, you can always change this to a curve to create an equal measurement all the way around for each individual step. And if we wanted to make the stairway 2 foot longer for a total of 5 feet, we can just simply move this line over around the perimeter like we did here to create a 5 foot wide winder type stairway with 6 steps. And hopefully that makes sense. And again, I think you can use the measurements that I have here for the 6 foot square along with the instructions in this video to lay out a stairway with this type of design. In this video, I will provide you with a method or a few methods that might work for you if you have a foundation that is not square. So let's go ahead and get started by looking at a foundation that is square and that all of the edges are nice and straight. And then we will go ahead and deform the foundation by adding a little extra materials at this corner and this corner here. So again, this part of the foundation is square. The red area would be out of square. And let's go ahead and zoom in on that to give you an idea of what I'm talking about. And keep in mind that the anchor bolts have not been moved yet, because if you have an out of square building foundation, there's a good chance that the anchor bolts might be moved over enough to where you won't be able to use the existing anchor bolts in the building foundation, and then chipping off the concrete later. But don't worry, you can always use epoxy anchor bolt systems, and I do have other videos on that. So if you are going to square up the foundation and it needs to be built with specific measurements, then you might end up with a situation like this here. If not, I'll provide you with a few things you might be able to do to make the foundation work and create a square building. So now that you have a pretty good idea what we're dealing with and the sections that are out of square, let's go ahead and remove the bottom framing sill plates, because this is what we would be dealing with anyway. The foundation would look something like this. And the first thing I want you to do will be to create some type of a square or rectangle inside of the building perimeter so that we can measure the areas to find out what part of the building isn't square. And if it's possible, try to avoid odd numbers like this, especially with fractions, because it will be a lot easier if you can have some type of measurements that are in feet without any inches or fractions, like we have in this example here. Next up, just to give you an idea of what we're still working with, let's go ahead and install the framing plates where they will create a 15-foot by 20-foot building and provide us with a good starting point for this project to fix everything. And another thing I want to point out is that you might be able to reposition your square or your rectangle by moving it a little bit in either direction, if that's going to work a little better for your project. Now, I went into extremes here, and obviously this wouldn't be better for this project. However, by shifting your rectangle or your square just a little bit, it could make a big difference on your project as another way that might benefit you somehow when trying to square up a building. Next up, let's go ahead and take a look at a method that I believe might be the easiest way to position all of your wall framing plates. However, you could do this by simply measuring off of these lines, if that makes sense or will work for you. And it might even make a little more sense once I walk you through this part of the project. So I'm going to take a framing plate or a couple of framing plates, whatever I need, to create the length of the walls I need for the exterior of the building. So here we're using a 20-foot long board or two 10-foot boards, and I can simply slide them over in different directions until I come up with the perfect measurement here, which in our case is going to be 10 1/16 inches, leaving us with 7/8 of an inch of the concrete footing sticking out past the wall on that side and practically nothing on this side. So the key here is to keep this measurement the same. And if I go over to the other side and I think that the wall framing plate needs to be moved over in this direction or moved over a little further this way, then I can readjust these measurements. Again, though, the key is going to keep them within the boundaries of the square and not have 1 foot 1 15/16 on this side and then go over to the other side and have 1 foot 1.5 inches. The next thing we can do will be to mark the ends of the 2x4s that we can use to snap a straight line or create a straight line that will end up representing the exterior of the wall framing. And don't worry about it if somehow you make a mistake and you need to move it over a little bit in either direction. You're going to be able to do that before you install the walls or even lay out the wall framing positions permanently. And here's an example of what the layout lines would look like. They're going to be the width of the wall framing plate, and we're going to be able to see which anchor bolts aren't going to work or which ones won't work as well as the others. Let's go ahead and install the framing plate to give you an idea of what I'm talking about. And we can see where these three will work. This one here won't, or won't work as well. The next step will be to find the layout or wall framing lines for the other walls. And we're simply going to do that in the same way. So no need to go through this process again. Just simply repeat what you did to position these walls over here. And again, if you move one of the framing plates a little bit, make sure that you move the other one so that you have the same distance between the line you're using in your square rectangle and the outside of the wall framing plates. They've got to be the same. And after you have created your straight lines, you can go ahead and install your wall framing plates and then chip off the rest of the concrete with a chipping hammer if needed to make the foundation work with any of the materials you're going to install on the perimeter like siding or stucco. However, if you're not interested in chipping the stucco and you can change the width and the length of the building, then you might be able to move the wall framing plate over. Here we simply moved it over an inch and it's going to be sticking off of the building foundation on this side to where we can add materials instead of removing them. It's going to be a lot easier to add some type of a concrete or cement mortar than it will be to remove it. But keep in mind that we're still having a problem with our anchor bolts. That might require you to add additional anchor bolts. Another idea might be to just move it over a little bit to where you don't have to chip off as much of the building foundation. So if you remember in the previous example, we were chipping off an inch. In this example, we'd be chipping off about a ½ inch on this side and then adding about a ½ inch to the other side. But if you look here, it looks like all of the anchor bolts are going to work, providing us with something else that might work a little better. And my last suggestion in the video would be to use a wider framing plate, like a 2x6. So instead of having a 2x4 wall, we're going to use a 2x6 wall and keep the inside line the same, and then have all of the anchor bolts work out of the wall framing sitting on top of the building foundation along any point of this particular wall to transfer the load to the building foundation. However, we will need to add a lot more material to the building foundation on this side, and that is if we need to. I've seen plenty of homes built like this where they don't do anything and simply let the wall framing plates hang over to create a square building on a building foundation that is not square. In this video, I will provide you with a few things to think about when locating windows on your home. And I do realize that there are a lot of people out there doing their own remodeling and even building new houses who might need a little more information about locating their windows in a single-story house. So let's go ahead and get started with the number one location you're going to be looking for, and that would be to center the window in a room. And all this means is that the distance from the wall to the window on both sides will be exactly the same. And of course, the next thing on the list will be the height of the window. These are usually going to be the same as the doors in the house. And most doors are 6 foot 8 inches tall, and the rough framing height for a door header, bottom of the door header, is usually going to be 6 foot 10 inches on a home with 8 foot ceilings. If you have taller doors, you have a 7 foot door or an 8 foot door, then you might want to raise the windows. Once you start raising the height of the windows, there's a good chance you're going to be increasing the height of the window. So the average person will have access to open and close the window. And another thing you need to keep in mind is that there are usually minimum heights for windows of 42 inches. However, you need to check with your local building department to verify that measurement, along with a minimum of 20 inches by 20 inches for the opening to get out of the window in case there's an emergency like a fire. Now let's go ahead and get back to the window locations. You can lower the sill height or raise it. However, you're usually not going to raise the top of the window. And you might not be able to see it from here, but if you want the top of the window trim and the door trim to line up, you better spend a little more time trying to calculate the height of the window opening also. This is a common problem. I see it often, especially when the windows are within 12 inches of the door. And I cannot tell you how many times I run into a situation where I see the top of the door trim a little higher than the top of the window trim. Next up on the list, light switches and electrical outlets could be another problem for your windows, especially if the windows are going to be a little longer and closer to the doors. And this is another problem I've seen regularly, even with professional home builders. So make sure that you understand how wide the electrical light switch is going to be, or even stacking the electrical boxes if necessary. You might need 4 light switches where you could always use 2 light switches on top, 2 on the bottom. Another thing to consider would be to make sure that the window is far enough away from the doorknob or the locking mechanisms on the inside of the house to prevent someone from breaking the window or breaking a part of the window and then reaching their arm in and unlocking everything to gain entry into your home. Another problem you might run into when trying to figure out the locations for your windows will be when you run into a situation like this where you don't have any room for the electrical outlets. And if that's the case, you can usually run them underneath the windows. However, if the windows go all the way down to the floor, then the outlets might need to be located in the floor, leaving us with another thing that we might not have considered when figuring out where we want to put the windows. And even though I mentioned centering the window in the room, you can center a window in between the wall and the door. However, I actually worked for a person one time who wanted the window centered in between the end of the door trim and the finished drywall. And this wasn't a problem for me because it was specified on the plans. However, it would have definitely been a bigger problem if I didn't notice it on the plans or wasn't notified. Next up, let's take a look at corner windows. It's not uncommon to have the windows in the corner right next to each other. However, this could create a problem for the finish carpenter. Now, most of the finish carpenters I worked with can figure this out and make it work. However, if the architect wants to run the trim, the wood trim, all the way around the windows or create another effect, you need to know about that before you frame the house or do the remodeling of the wall framing for the windows. Again, I've ran into a situation like this before also. And of course, here's an example of what it would look like if you use 2 different sized windows. This is not a common construction practice. However, I thought I would throw it in there to provide you with an example of what it would look like. Another method for installing corner windows might be to have the windows come off a specific measurement, maybe a few inches off of the corner. However, this example would not be common because the windows would now be out of proportion. You would have a longer distance on one side than you would on the other. However, structural posts or plumbing, heating, and electrical could force the designer to do something like this. And in my opinion, problems like these should be solved during the design phase and definitely not during construction. Another situation that might look a little awkward to a home designer would be to have a larger or smaller window a little further away from a corner. Or a situation like this might not be acceptable to a designer where you have 2 windows at opposite edges of the walls that would be different sizes also. Again, this looks a little odd and might look even worse from the outside. So let's go ahead and fix that with windows that are the same size. And of course, another situation that wouldn't be common when you pull one window away from the corner and you have another one right up against it. However, it wouldn't be a problem if they are the same distance, maybe 1 or 2 feet away from the corner. Or if we throw one in the middle and have each one of these distances the same size, or even change some of these measurements up. Have the same measurement here as we do over here, and then center this window in between these two windows. And by now you're probably getting a good rhythm of where I'm going with all of this. However, you could run into a situation like this as a builder and question the architect or designer, only to find out that they're going to put a large piece of furniture in that room. Another problem you could have when trying to figure out the locations of your windows, especially when dealing with a bed or a sofa. And this is usually not going to be a common building practice, because once the dresser is gone, now you have an odd situation, taking us back to a situation that would look more like this. And if someone put the dresser in here, they would just simply cover up that one window. And another situation that wouldn't be common would be to raise or lower windows that are the same measurements away from the corners. However, if this is the look you're looking for, go for it. I do not want to discourage any creativity in this video, as long as you're doing it for a specific reason. So with that said, let's go ahead and install a longer window over here. Now wait a minute, if you don't like that idea, let's install a longer window here so the bottom of the windows line up. So enough of the creativity, let's go ahead and wrap this video up by taking a look at a small house. And this is actually one that I have more videos on. Let me know if you want me to put a link in the video comment area to those videos. And let's go ahead and start with the window here, centered in between the door and the wall. And this window here, centered in between the door that is open. We're centering it in from this point here to this point here. However, this window could have also been centered in between this point here if we just drew a line through here and this wall here. We do not have a window over here because the bed is going up against this wall. However, you could have put a window in there, or you could have had a couple of small windows on the side of the bed, and then no windows where the closet is, a window centered in between the bathroom walls. And this is going to be a smaller window. I believe it's only 12 inches tall and will also be a little higher than the other windows. Then we have a window that's basically centered in between the front of the refrigerator or the cabinet line here, if we ran this cabinet line through, because you could always buy a larger or smaller refrigerator to mess this up. And even though the sink is off a little bit, it's usually a common practice to center the window in back of the sink or center the sink in front of the window. Next up, let's go ahead and just kind of zip through a little close-up here to give you a better idea of the windows, maybe the sizes. And you can see here that this is a 4010. It's 4 foot wide by 1 foot tall. This window here is 5 foot wide. You can see 5 foot measurement here. And it's 3'6" or 42 inches tall. Next up, let's go to the outside of the building, where we can see by adding trim to the outside of the door, we'll create problems for our straight lines here. This window should have been raised a little higher, or it should have been adjusted for trim to go around it and be positioned to where the top of the trim lines up. And you can see where if this window wasn't here, it really wouldn't be a problem. You might not even notice it because this window here is so far away from the door. Let's go to the kitchen wall, where we have the kitchen sink window. And whether or not this has trim around it doesn't really matter because there's nothing to line it up with. Another thing to consider with exterior views. And of course our bathroom window a little higher to make the tub surround work. The top of the bathtub surround needs to be taken into consideration. This window is just going to be a little out of whack. Not much you can do about it, unless you want to raise the rest of the windows around the entire house. And let's go ahead and wrap this video up by just taking a quick tour of the inside of the house to give you an idea of what the windows look like and why the bathroom window needs to be raised a little higher than the other windows. So here is another one of those tips that might need a little more thought when installing a clean out. And that would be as to whether or not you're going to put it above the sanitary tee or below it. And when it comes to a sink, I don't think it's really going to matter that much, because you can always take the sink trap arm apart and run a snake through here And of course, that's the benefit that I would be referring to if you put it above the T. If you have a clog in this area right here, then you can usually unscrew this part of the clean out and then run a snake through here and through the clog to get rid of it, making it a lot more valuable to have the clean out above the T than below it. However, this will not always be the case. And that might be a situation where you have a sink draining into a wet vent to where you need to have a larger diameter pipe running up with a larger clean out. And I'm not saying you can't add another clean out. It just might not be necessary as long as you can take the sink apart. You can take the sink trap arm apart to clean out any clogs that would be in this area right here. And of course, another thought of mine I'm always thinking about when installing a clean out is what's going to happen to the area where the flooring is. When somebody unscrews this fitting right here and then water drains out onto it. Carpeting, wood flooring, this could be a problem. And I'm not about to suggest that you don't install the clean out, especially if it's required by your local building codes. However, if you have a situation where you have a wood framed floor and a crawl space underneath, then it might not be a bad idea to put the clean out fitting in the crawl space area, even if it's going to be below a T-fitting or another fitting that could get clogged. That way, all of the water that's going to be in the pipes when you unhook the clean out plug is going to drain into the crawl space and not onto your floor in your living room. And I do understand that this isn't rocket science. You don't need to put that much thought into this, and clean outs usually don't cost that much and do provide homeowners with cheap insurance, especially if it prevents you or a plumber from climbing up on top of the roof because you have to get to this area over here because there isn't a clean out above the T. And of course, that would prevent you from breaking any of your roofing tiles or from either one of you falling off of the roof. And with that said, some of the information I just provided you with might actually be a little more important than I'm making it out to be. Here is another problem that you might run into one day, and it's going to have something to do with different materials used to finish different parts of the stairs or the floor. So for example, you might have a thicker carpet or a thinner piece of lumber that could create a problem for your riser variation building codes. And since most stair builders don't take into consideration the finish building material thickness for the lower floor, upper floor, landing, or stair steps, then you might end up explaining this one, or should I say trying to explain this one to your local building inspector. So if the entire stairway has the same riser height at the bottom and on every single step, at the landing, at the bottom of the landing, at the top of the landing, and at the top of the floor, and you're going to use the same thickness for the finish of the entire stairway, then you're not going to have a problem. You started with 7.5 inches and now you have 7.5 inches. And I can't think of any case where it would matter what the thickness of that material was. So for example, if it was a 1/2 inch, a 1/4 inch, or 1 inch, you're still going to end up with every single step being the same height. However, this won't be the case if I don't add any materials to the bottom level floor, or I'm going to add a very thin material, creating a 3/8 of an inch riser variation difference, which is usually acceptable by most building departments. And of course, this right here works at the bottom or the top. It's not going to work at the landing, where we just went from a 7 7/8 to a 7 1/8 inch riser height, creating a 3/4 inch difference in the riser variations. This is the problem that most designers and builders have a problem wrapping their mind around. However, that will not be happening to you because I just showed you what this particular problem would create. And if for whatever reason you're having a difficult time wrapping your mind around that one, let's go ahead and take a look at this one, where we're going to add a thicker material to the top of the landing and end up creating the same problem, except now we've took the 7 1/8 inch step from this side of the stairway and shifted it over to this one. The 7 7/8 got shifted over to this one, and providing you with a good example of what's going to happen if you add thicker materials or thinner materials to a stair landing without making the necessary compensations in the framing while you're building the stairs. Here is another one of those things most builders rarely think about. However, I'm willing to bet that the large home builders have been thinking about it for years and doing it. And that's the fact that our roof sheathing could cost us a lot of money in wasted time and materials if this particular measurement is incorrect. And all I'm suggesting that you do is figure out what the measurements are going to be for the area that is going to be covered in roof sheathing on your project. And to do that, all we need to do is take into consideration the pitch of the roof, or the angle slope of the roof, the width of the building, the design of the roof. For example, is it going to be a hip roof, a shed roof, or a gable roof like we're looking at here? And of course the roof overhang. So what we have here is going to require one 4-foot sheet of plywood and another piece that's going to be 1 foot 3 1/4 inches, which isn't going to be that big of a deal because this measurement here, 1 foot 3 1/4 inches, is just a little bit shorter than 16 inches, suggesting that we'd be able to get 3 pieces for this section here out of 1 sheet of plywood with very little waste. Or we can add an overhang to the building that will allow us to put 2 full sheets of plywood in here, or 1 full sheet and another sheet that's just going to be a little bit smaller if that's going to work for our design. However, if it isn't, we can simply change the pitch of the roof or make the building a little wider or shorter, or reduce or increase the length of our overhang. So again, in this example here, we have a 10-foot wide building with an 8 12 roof pitch, and the length we're going to need here so that we can get the perimeter nailing on our gable roof and make our engineer happy is going to provide us with 1 full sheet of plywood, 4 foot wide here, along with an 1/8 inch gap in between those pieces, and then of course another 2-foot piece of plywood. And if we want to use 2 full sheets, 4 foot and a 4 foot, we can adjust our overhang, the length of the overhang, to make everything work out accordingly. And hopefully by now, most of you are starting to get an idea of what's going on here. However, for those of you who watch my videos often, you know that I don't stop there because some people still aren't getting it. So let's go ahead and make the building a little wider, 14 feet, change the slope to 5 12, and see what we come up with here. 7 foot 7 inches, a little shorter than 2 sheets of plywood, or OSB, something that is 4 foot wide. And you can see here where we're only going to have about 5 inches of waste on 1 sheet of plywood. Something like this is not going to be as big of a problem as something like this with a roof overhang that's going to require a larger piece than 24 inches here, especially if we need to have our perimeter nailing. So for something like this, we're going to have a full width piece of sheathing, and then another one a little shorter with about 5 inches of waste, and then of course a 2-foot piece of sheathing that isn't going to work. We're going to need to cut this a little bit longer. And if we do that, that's going to create a lot of waste. If I need a 2-foot 5-inch wide piece here, then I'm going to end up with a piece of scrap, the other side of the plywood, that I'm not going to be able to use in this area of the roof, or I'm not going to be able to use that piece at all if the engineer is requiring a 2-foot minimum width in our roof sheathing. However, keep in mind we could always reduce the length of the overhang or reposition the sheathing if that's going to work for you. So here we would have a full piece of sheathing, and a 2-footer, providing us with a 10-foot length. If I needed to make this a little shorter, I could reduce the pitch of the roof or reduce the length of the overhang. Again, the main point I'm trying to drive home in this video. Next up, let's take a look at the biggest problem that I usually run into, and that's going to be when you have a small piece, 2 4-footers to equal 8 feet, and then another piece a little less than 7 inches on a building with an 8 and 12 roof with a 14-foot span, suggesting that to fix this particular problem, we're going to need a full piece and then a piece that is going to have a 2-foot minimum. We cannot have pieces that are smaller than 2 feet sometimes on some projects. So we're not going to have any waste here, because if we cut a 4-foot piece of plywood in half, we're going to end up with 2 pieces that are 2 foot wide. However, that's not going to be the case over here. We need a piece that's 2 foot 7 inches, suggesting that the other piece of lumber we're going to have to get rid of that's going to be 1 foot 5 inches wide, if I did my math right, and provide us with a little bit of waste, unless we're going to add an overhang. So again, we could have a 4-foot, a 2-foot, and a 4-foot piece to solve this problem if it's going to work on our project. Now keep in mind that I'm not suggesting to save money on the roof sheathing that you spend more money on your roof framing by purchasing longer rafters or additional materials. Just simply throwing out something that might help you save a few dollars on your next project. And in our last example, I will reduce the slope of the roof to a 6 and 12. And you can see here where we end up with something just a little bit under 8 feet. If we just want to use 2 pieces of sheathing, or we can add a 2-foot piece here or a 2-foot piece down here, depending upon what's going to work best for our project. And the last thing I want to point out, and truss manufacturers have been doing it for years, and that would be to use fractions. For example, a 5 3/4 inch number might work better here, or even a 6 1/4 inch number might work better here. So don't be afraid to change these numbers if it's going to work better for you and your local building authorities allow it. Here is another home edition roof design idea. Somebody sent an example of their existing house where they have a patio, a low sloping roof here, and a home like this that looks like it has a couple of home additions already added onto it. And they would like to add a new home addition here and then have a gable roof here. And hopefully by the time I am finished with the video, you, along with them, will have a few more ideas on how you can do something like that. And for those of you who might not have understood what you were looking at in the last example, let's go ahead and provide you with another example here of how the roof and the roofing might be assembled. Next up, let's go ahead and take a look at our gable roof for the patio here. And I really don't think this is going to be too difficult. You might be able to use the existing slab that you have or create something with a 45-degree angle, which is what we have here. And of course, with the house the way it is, you're probably going to end up with a situation like this where you have a small piece of fascia board here. However, let's not forget that you might be able to remove the fascia board and then bring this line up a little further and get a little creative there if you don't like that look. And for the home addition, let's go ahead and start with a gable roof on this side. And you're simply going to add the home addition and then extend this roof over the other roof to create 2 flat planes and a gable roof. However, on the other side, it is going to be a little more difficult. We are going to be dealing with a couple of funky sections here. Now in this example here, I brought the gable roof out to this ridge line here. You can stop the gable roof anywhere you want to. However, it's probably going to be better if it lines up with one of the ridge lines. And in my opinion, it's going to be better to line it up with the lower ridge line, even though this section right here is going to make it a little more difficult for us. And we're simply going to extend the other 2 sections of the roof up which would look something like this here. So this line here will be flat. This section here will plane in with the other section of the roof. And we'll end up with something that looks like this. And keep in mind that the pitch of the roof and the offsets in the building might change your design a little bit. Next up, let's take a look at this funky section that we have right here. So here we have it just kind of going over an open area. However, it can be filled in by installing a piece of fascia board or exterior finish, whatever exterior finish you're going to be using for the side of your home. Like I said, we just got a little funky area with this one here. However, everything else seems to be looking okay. A little chopped up. This roof right here seems to have a lot of zigs and zags in it. And as another option, I think this one's going to work a little better and be a little easier to build, would be to install the gable end on the other side of the building. And you could always have the gable stop at the ridge line here. And if you like this design, you could always extend each one of the sections of the other roofs up to create your flat roof planes or surfaces. And of course, this design right here will provide you with 3 different ridges. And of course, another option for this type of building. Now, if you don't like this section right here, because it's going to require a lot more work, and this design right here actually looks the best out of all of them, in my opinion, and will require you to install a roof drainage cricket over here. Now, keep in mind that if you live in an area where it snows, this could be a snow trap. And if that's the case, you might want to choose a different design. So there it is, another video to help some of you figure out exactly how you can build a roof like this if you have a similar floor plan. In this video, I will provide you with a simple concept you're going to be able to wrap your mind around, and that will be the reason why most of the time plywood siding isn't going to work for the structural engineer. And the reason for that is because most walls are going to be a little taller than the plywood siding. And even though we can get larger plywood, that could increase the cost of the project. And another alternative would be to lower the height of the wall to solve this problem. And another thing I'd like to point out is that most of the time, this measurement here is going to be more like 8'1", and that could be for a variety of other reasons also. You might have lumber that's a little bit larger than 1.5 inches, and if each component is not assembled tightly and securely together. And trust me, I've measured plenty of these, and this is the number that you're going to come up with most of the time, creating even bigger problems for your piece of plywood. So let's go ahead and take a look at what happens most of the time. And again, this is something I've seen more than once, and that's the fact that the plywood siding will be installed either even with the bottom plate or held up a little bit so that you can get the top plate nailing, which is usually required for structural shear panel. And most of the plywood siding will be providing some type of structural shear value. Next up on the list, since it is siding, it's usually going to be required to drop down below the bottom of the wall framing plates or the top of the building foundation. And the reason for that is because any water that gets on the plywood siding needs to go down over the foundation and then work its way down to the ground, and not have the water go down the face of the siding, hook around the bottom of the siding, and then go in between the framing plate and the top of the foundation, and then enter the interior of the building. And both of these examples will work for the engineer. You're going to be able to get enough structural nailing on both sides. You're going to be able to nail the bottom plate to the plywood siding and have it be approved by an engineer. However, that's not going to work at the top. On the one that we lowered, we're not going to be able to nail into the top plate. And since we're not going to be able to have one without the other, we've got a problem. Next up, let me show you what most people do, and I've even done this myself. and that will be to lower the plywood a little bit below the top of the foundation while angling the nails. You can see here where angling the nails might not be an acceptable practice to a structural engineer. However, I've seen plenty of building inspectors pass this without a problem because it's usually difficult to see even if you know what you're looking for. And of course, this is what it might look like if you have rafters with a seat cut. However, if you are using trusses, you could end up with a larger gap at the top, and that gap can usually be covered by a piece of wood trim, so it won't be a big problem, where it might not be the same on the bottom. So let's go ahead and whip down to the bottom, where we've lowered the siding about 3/8 of an inch below the top of the foundation, providing us with some sort of overlap, and in some cases this might be enough. However, if it is not enough, then you might want to try installing a piece of metal behind the plywood siding that will divert the water away from the top of the building foundation. And don't bother asking, I will not be able to provide you with the type of metal or the thickness, the width. That's all going to depend upon your project and quite possibly local building authorities' permission, but would recommend something that's not going to rust or deteriorate within a few years and defeating the purpose of actually putting it on in the first place. And I don't recommend installing the building paper to where it's going to be exposed. The metal can be exposed and painted if that's going to work better for your project. So make sure that you raise the building paper up a little bit. And if you need to, you can always raise the plywood siding up a little bit to provide you with a little more nailing at the top if you need it, to get the nails into the building top plate to make the engineer happy. And again, I can't stress this enough. Even though I've used this and think that it's going to work just fine, especially if you install a nice thick piece of sheet metal. And I'm going to go out on a limb here. After you've installed everything, make sure that it's maintained so that it does not deteriorate in the future, and you can get as many years as you possibly can out of this particular process of construction. Here is another one of those videos that could save you a lot of frustration and money, and it has something to do with a tool that some people use to clean out sewer drain pipes, and it's often referred to as a drain bladder. The tool connects to a garden hose, and then you slide it into a plumbing pipe and then turn the garden hose on, and this causes the drain bladder to expand enough to seal the plumbing drain pipe and force water into it to dislodge loose objects that might be clogging the drain pipe and allow the water from the hose to clean out some of these particles also. And as far as my experience goes with one of these, it was years ago and it didn't do anything because I was dealing with tree roots. And I'm not about to suggest that this is going to solve all of your problems. However, by the time you're done watching this video, you're going to have a little more knowledge about where to place it. And of course, one of those places might not be in the toilet bowl unless the clog is actually in the toilet here somewhere. Because if it isn't, if it's located farther down the line in the plumbing drain pipe, and there's enough water pressure, not enough to get rid of the clog, but enough to force the water out of the plumbing vent. And this might not be that big of a deal if the roofing is installed correctly. However, it could be a big deal if it breaks the wax ring seal, allowing water that will be under pressure because the hose is going to be turned on to spill into the bathroom floor area. And you can stop the video right there if you get a pretty good idea how much damage one of these can do if it's in the wrong location. However, if you're not quite sure, let's go ahead and provide you with a few more examples. And in this example here, we have a kitchen sink, a laundry drain pipe, a sink in the bathroom, a toilet in the bathroom, and a bathtub. These are all the drain lines for this small house. And the same thing could happen if you end up sticking one of these drain bladders into the kitchen sink and the clog isn't located in a convenient spot. If the clog is located somewhere in here or even past this area a little bit, but it's not something solid enough that could not be dislodged with the water pressure, then something like this probably won't happen. Another problem you could be dealing with will be fittings or sections of the traps. That's probably going to be this section here or this section here, but probably not this section here on the traps that are not glued together. You're probably not going to have this problem if these fittings and connection points are glued to the other parts of the plumbing. So it wouldn't be a bad idea to use a lower volume of water, just a little bit of water, and not a lot of pressure when working with some of these tools. Next up on the list, let's go ahead and pretend like the clog is somewhere else. It is not in this section right here, and instead it's down here a little bit. We're going to take our drain bladder tool and lock it into the clean out, and then pan back and see exactly where the water's going to be going if it's not going to unclog the drain. And in this situation here, again, we have this area sealed right here, and we don't have this area sealed here. And if the clog isn't going to dislodge, then the water can come out of the sink or out of the vent pipe again. However, that will not be the case if we move the clog a little further down the line. Because if it's located here and we're going to be running the water into here, we now have an alternative path for the water to come up. And of course, if that happens, then we could have water coming out of the wash machine drain line. So again, the water's going in here, and we don't have the hose on full blast, right? We have somebody standing in this room, someone standing in some of the other rooms. And if we see any water coming out of any of the sinks, bathtubs, toilets, showers, or even the laundry drain pipes, then you're going to run as fast as you can and shut the water off, and that might be your first sign that you need a plumber. In the next example, let's go ahead and move the clog a little further down the line. And if this is where it's located in this particular house, we have another avenue for the water to travel. Like I said, if you don't have somebody checking these fixtures, checking the other parts of the house, and you're standing over here with the hose on full blast, you could end up with some serious water damage. And if we relocated the drain bladder tool to this part of the plumbing, we could end up with the same situation. We have a clog here. The water from here could enter into these areas here. And by now you're probably getting a pretty good idea how many problems you could end up with if you're dealing with a stubborn drain pipe clog and hoping that it will be dislodged with water pressure. Now, another thing you need to keep in mind is that these pipes can hold a lot of water. And the clog is right here, and you start filling these pipes up with water, you can actually put more pressure on this clog, forcing it to go away and hopefully solve your problem. Next up on the list, let's go ahead and take a look at another insertion point for the drain bladder. And in this situation here, we are going to shove it a little further down the pipe so that it blocks off this area here and water will not be coming back into these pipes, in hopes of clearing a clogged pipe a little further down the line. However, even if you dislodge one clog and you have a partial clog, you could end up pushing all of the debris from here down the pipe a little further and adding more debris to this clog here and making it more difficult to clear. So that's about all I have to say on this subject. There are other problems that I have found with other drain pipe cleaning tools, and I do plan on making more videos about that in the future. So with that said, feel free to share any stories you have about a variety of different plumbing tools, including the plumbing drain bladder, along with your success stories. Feel free to leave those in the comment area for everyone to see. And don't forget to hit the thumbs up button if you enjoyed watching the video or learned something new from it.